हाँ दोस्त। यस यस। এ বা ম্যাথে, রে ম্যাথে তো কিছু বুঝতেছি না রে বা। আমি শুধু আরে
ভাই
ম্যাথে কিছু আজকে সিরিয়াসলি যদি কিছু না বুঝি প্রথম 10 মিনিট ক্যামেরায় যে রেকর্ডিং অন করে দিয়ে আমি এখানে মুভি দেখা শুরু করে দেবো, সত্যি কথা বলতেছি। যদি কিছু না বুঝি, যদি বুঝি তাহলে ভালো, না বিড়ি টিড়ি খাই না তা মুভি দেখা শুরু করে দেবো
ভাই
সত্যি, যদি কিছু না বুঝি।
ভাই গতদিন
কই রায়ন, কই রায়ন, কই রে? না, টিচার আছে, টিচার আছে, টিচার আছে, টিচার আছে। নেহা লসি।
Hi.
নেহা লসি।
Hi.
Hi, teacher.
হ্যালো
টিচার অনেক সুন্দর আছে। আবু ভাইয়ের মতো বলো, তুমি অনেক সুন্দর। থাক ভাই, ইংলিশে না বলি। এই যে পাগল, এদের রুটিন দিয়ে দিচ্ছি আমি, তাও যদি জয়েন না হয়।
তাহলে কত তুই বেরিয়ে দেবে? হ্যাঁ।
Hello, everyone. I hope you can hear. I think you can hear me. Good evening. Okay. We always begin to color in our class with a bear ring, right? Now the first one. Here the first one. 侯赛德
Present, ma'am.
Second 6210 Okay, second one 6210 Okay, not here 1222 1222 cube 2 Maybe another here 任北 Chinese name is 任北1219 1219 6211 Okay, present. Next 1218
Yes, teacher.
Okay, next 1208
I'm here, miss. I'm here.
Next 1214 Okay, present. Next 1213
Present, teacher.
Okay, next 1209
Yes, Laushi. Yes, Laushi. I'm here.
Next Sabet
Present. I'm present.
present. Okay, 6207
Present. This is like
present. Hello, this one. 6207 Not here. 1220
I'm present.
present. 1207
Present, miss.
Okay. Next 6206
present, miss.
12006 Hello. Okay, present. 1210
Present, miss.
1204
Present teacher.
萨基布
Present Laushi.
白明1203 maybe not here 6212 Hello 6212 also not here 欧舒文
I am here. 205. I am here. I am here. I am here, teacher. Yes, I am here.
next 蕾蕾
How long?
next 艾莫斯 OK next 1216
Present, Miss. Present.
OK next 1215
I'm here, miss.
next 1202
Present Laushi.
next 6203
Taulaushi.
6204
Taulaushi.
6208
I'm here, teacher.
next 1201 OK next 6209 Hello 6209 1212
Teacher, I am present.
吉朗于连check it this one 6210
Yes, present teacher. Present teacher.
OK next 1
Present Laushi.
2 parent so this one one two double two this one okay not here right 任北 Hello 任北 okay not here next 512 1 2 double 2 0 1 double 2 0 oh this is here this one sorry 6207 6207 this one another here 华安明 Hello 1203 okay
I'm here. Present, teacher.
okay next 6212 Hello this girl 6212 this girl Hello this girl 6212 not here next 6209 6209 6209 this one Chi Lang, Yu Lian, not here. Okay. Now we begin our class. BI, close this shadow. We should first review. Last time we have learned the definition of fractions, and we learned function notation. We learned the domain and the range, and we also went to the graphs of functions, and we learned even and odd. This is odd functions, even and odd functions. A function is even. This means f minus x is f(x). This is even function. An odd function. This means f minus x is equal to minus fx. Odd and even function. And today we will learn some special functions. Some special functions, and they are graphs. First, we will learn the constant function. This means f(x) is a constant, a(x) is a constant, and the domain is all real numbers, And the second one is a sum function. This means sin x is equal to Vx is greater than 0 is equal to 1. Vx 0 is 0. Vx less than 0 is minus 1. And we can give the graph of some function. Here is 0. X is greater than 0. Y is 1. If this is 1, the greater than 0, y is 1. So this is this horizontal line, and we know x is 0, y is 0, y is 0, and x less than 0, y is minus 1. This is minus 1, like this. So this is the graph of some function. Function. A constant function, a sum function, and also have two special functions. Among the functions that will often be used as examples are two very special ones. The first one is the absolute value function. We write like this. This is absolute value, and the greatest integer function. This is greatest integer function. We write like this. The greatest integer function. They are defined by first absolute value function. First absolute value function. We write absolute value x is equal to. This means x is greater than x is greater than 0. Write this is x. X is less than 0, write this minus x. This is absolute value function. This is the symbol of this one. If x is greater than 0, we let write absolute value of 4 is 4. Absolute value of minus 4 is also 4. So this means the x, this one, 4 minus 4 less than 0. This is x. The absolute value of minus 4 we know is minus fx. Minus x is minus 4, so it's 4. Okay, this is the definition of absolute value functions. And the greatest integer function. The greatest integer function we write like this. This means the greatest integer less than or equal to 0. This is greatest integer. like this. The greatest integer less than or equal to x. Now, please tell me this one. No, this is Vx is 2.1. Please tell me the greatest integer function we have. This is equal to the greatest integer less than or equal to x. Here, this means x is 2.1, right? So the greatest integer less than or equal to 2.1 is equal to, anyone else? The greatest integer, here Vx is 2.1, please tell me. Equal to, anyone else? Don't know? You tell me, do you know this? The greatest integer. The greatest integer less than or equal to 2.1. Please find this number. The greatest integer less than or equal to 2.1. About it. The greatest integer less than or equal to 2.1. Please find this number. Anyone else say it? The greatest integer less than or equal to 2.1. Which number? Which number? Just told you which number. If you know this word, this sentence, you will find which number. The greatest integer less than or equal to 2.1. Please tell me which number. You know what means the greatest integer? Right, it's true, right? You don't calculate it. Just read this sentence. The greatest integer less than or equal to 2.1. So this is true, right? Now, please tell me this one. This one. Vx is 3. The greatest integer less than or equal to 3. Please tell me this is equal to 2? No, it's not 2. Less than or equal to 3, right? This is 3. The greatest integer less than or equal to 3. This is 3. Okay, and please tell me this one. This is Vx is minus 1.1. Think about it. The greatest integer less than or equal to minus 1.1, right? This is equal to minus 2, right? Less than or equal to the greatest integer, so it's minus 2. Okay, minus 2. And then if you know this, you can find the greatest integer for this one. The greatest integer less than or equal to minus 4.3 is equal to minus 5. This is the greatest integer less than or equal to minus 4.3. So this number is minus 5. Okay. How about the other students? Any questions for the definition of the greatest integer function? And now we will give the graph. First one is absolute value function. Absolute value function. X is greater than 0 or equal to 0, y, this is x. So we have like this, y is x, right? And x is less than 0, it's minus x. So like this. So this is a graph of y absolute value function. And now we will give the greatest integer function. This one. First, we should find some points. Okay, and please tell me this number. 0. The greatest integer function of 0 is equal to 0, right? So I write here 0. And please tell me this one. 0.5. This one is equal to the greatest integer less than or equal to 0.5. So it should be 0, right? So this means we find is also 0. This means belong a function in this interval. It always 0, right? X belongs to 0, 1. So this means 1, we know. The greatest integer of 1 is equal to 1. So here, 1 is not included. This means in interval 0, 1, we have always 0. But here, we know, at the point 1, this 1. So right here, it's 1, right? And we find in the interval, in this interval, for example, we have a point 1.8. The greatest integer function of 1 that's equal to 1.5 is 1, right? We found any functions belongs to this interval. The greatest integer function of x is equal to 1. So here, in this interval, this is 1, it's equal to 1. But here, at the point 2, we know y, the greatest integer function of this x is 2. This is 2. So right, this is 2 is not included. Yes, right. It's 2 here, right? It's equal to 2. And also we found in 2, x belongs to, x right here. X belongs to 3, 4. 4 not included. We find the function is this 2, this is 3. Two, 3. This is 2. Okay, x is 3. This is 3. Okay, with 3, 4. 3, 4. 2, 3 is 2. 3, 4, this is 1. It's 3. So the graph like this. This is just axis positive. Now we will analyze y-axis negative. Y-axis negative. First, we consider a function is because the interval, this interval, -1, 0 in this interval, we can choose a point. For example, minus 6, minus 0.6. Think about it. It should be 0, the greatest integer less than or equal to, minus 1, right? Okay, yes, minus 1 here, minus 1 here. But we know other point 0 is 0. So this is circle like this, right? And here, we axis minus 1 is minus 1. And then minus 2 to minus 1. Okay, we can say that minus 2, minus 1. We give an example, is minus 1.7, is equal to minus 2, right? Okay, here it's minus 2. We know we axis minus 2, so it's minus 2, like this. And consider minus 3. In an interval minus 3 to 2, find this is here, this is minus 3. Like this. So this means we have given the graph of the greatest integer function, right? Like this. I hope you can do it by yourself after we analyze it. Understand it? Okay, any questions for this one? Any questions? Right. Any questions? If no, we can continue. Okay, no questions. Okay, we continue. Maybe the concept review. The first one, the set of allowable inputs for a function is called the inputs. The set of outputs that are obtained is called the set of allowable inputs of a function is called input. It's called domain, D-O-M-A-I-N, domain, right? And the set of outputs is called read, right? Okay, for the second one, fx is 3x squared, then f to u. Please tell me f to u should be. F to u should be. Yes, it should be 3 times 2u squared. So we find is equal to 12u squared, right? 12u squared. And fx plus h. Fx plus h is equal to 3x plus h squared, right? We just replace x by x plus h. And the third one, maybe this is the we first calculate. Fx gets closer and closer to L as the absolute values of x increases indefinitely, and then the line y is L is called an asymptote for the function of f. This means in Chinese word, this is called 渐近线. Maybe I spelled T-O-T-A-T, and the number is T-A-T. Asymptote, A-S-Y-M, 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 T-T-O. O, A S Y N T T O P I C. Asymptotic line. A. Asymptotic line. This is called asymptotic line. 渐近线。渐近线。Okay. And here, the first f minus x is fx for all x in the domain of f. Then f is, yes, even at function, right? In the first case, the graph of f is measured with respect to the what? Y-axis, right? In the second case, it's measured with respect to x-axis. SIS, are you sure? AXRS, AXRS, axis, AXRS, written like this, right? Oh, this is, oh, sorry, this is not X, the origin, sorry, the origin. Origin, right? The origin. Okay, now we will learn the operations on functions. We consider two numbers, A and B, can be added to produce a new number A plus B. So two functions f and g can be added to produce a new function f plus g. This is just one of the several operations on functions that we will describe in this section. We will consider sums, differences, products, quotients, and powers. We consider functions f and g with formulas. Fx is x minus 3 over 2. Gx is the square root of x. We can make a new function f plus g by having it assigned to x. The value fx plus gx is equal to having it assigned to x is x minus 3 over 2 plus the square root of x. That is, we have like this. Of course, we must be a little careful about the domains. Clearly, x must be a number on which both f and g can work. In other words, the domain of f plus g is the intersection. This means all the common part of the domains of f and g. For example, this is the domain of f. This is the cycle domain of g. The f plus g, we find the domain is the common part. And the function f minus g, product g, and f over g are introduced in a completely analogous way, assuming that f and g have their natural domains. We have the following. For example, here, f plus g, when the domain is, we have the square root. So from 0 to infinity. Minus is also 0 to infinity. This is a product, 0 to infinity. This is over. Okay, crosses. We should notice, avoid or exclude 0 from the domain of f over g to avoid division by 0. So this is 0 is not included. Okay. And now we may also raise a function to a power. By f, this is power n, we mean the function that assigns to x. Assigns to x, the value is fx, with power n. Thus, if gx is the square root of x, gqx is the x, this power becomes 3 over 2. There is one exception to the above agreement on exponents, namely, Vn is minus 1, is g minus 1x. The reverse, the symbol f inverse for the inverse function, which will be discussed in section 6.2, thus f inverse does not mean 1 over I. Okay, we will this is a new function, an inverse function. This is not 1 over f. We will learn it later. And for example 1, let fx is x plus 4, the first root. Dx is the square root of 9 minus x squared. With respective natural domains, the first one occurs is minus 1 to infinity. The third one we can solve it is from minus 3 to 3. We find formulas for x plus g, f minus g, f product g, f over g, and by power. Let's give their natural domains. For the first one, f plus g. I think it's simple to calculate it. So we should find the common part. The first is this interval. So the common part is minus 1 to 3. And this is f minus g, the common part is minus 1, 3. F product g, the common part is minus 1, 3. This is f quotient. This is called quotients of f over g. We should notice that exclude the 3 to avoid division by 0. So 3 is not included. And f power. F power, this is power 5. We know this x plus 4 is 5 over 4. Notice this minus 1 to infinity. What? Avoid division by 0. Vx is 3. This is 0. Right? You see this one? Vx 0, x is 3, this is 0. We avoid this is meaningless because the denominator, this part is 0. So it's meaningless. We just avoid division by 0. Always, right? No. For this one. Always remember this. So 3 is not included. And now we will learn the new function. It's called the composition of functions. And we will use this function always, I think. Comparison of functions. Earlier, we asked you to think of a function as a machine. Right? This is a machine. We have input and output. It accepts x as input. For example, this is input x and works on x and produce output fx as output. If two machines may often put together in tandem to make a more complicated machine. So this means two functions f and g. We have two functions f and g. F and g. If f works on x, f works on x is input. So we can produce an output fx, right? If g or v, g then works on fx. This means we will regard fx as input. G, this is another machine, right? Another machine works on fx, produce gfx, because g works on fx. So write like this. This is output, right? This output. And we see that we have composed g with f. Composed g with f. And the resulting function is called the composition of g with f. It's denoted by g, the composition of g with f. And last, this is a new machine. We say works on x is equal to g fx, like this, g fx. And also, if input, x is input, g, this machine first works on x. We have an output is gx, right? And then f, this is another machine, works on gx. We have an output. This is f works on gx. We have output. This is a new output. Of course, they are usually they are not equal, right? Because the first is f works on x, and then g works on fx. But this we have the different. This is called 不同的顺序, or different order. This is called composition of G with F. And in our previous examples, we have fx is x over 3 minus x minus 3 over 2, gx square root of x. We may compose these functions in two ways. Because first, r we know works on x, because output is x minus 3 over 2. And if g works on, we think g works on fx. This is if g works on x, output is square root of x, right? If the input here, this is replaced by fx, this is g x minus 3 over 2. The output should be this one, x minus 3 over 2, right? G works on x, is the square root of x. G works on x over 3, x minus 3 over 2. It should be the square root of x minus 3 over 2. This is G. F first works on x, then G works on fx. And if, first G works on x, the square root of x, and then F works on gx, right? F works on gx. This means F, the square root of x, we can write. This means F works on the square root of x. F works on x is this. So f works on the square root of x. It should be the square root of x minus 3 over 2, right? This is we write is the composition of g with x. This is the composition of f with x. Do you know how to find gfx and fgx? Understand? Okay. Right away, we notice that g, we maybe read that g stroke f, that's not equal to f stroke g. Not the same. Thus, we see that the composition of function is not commutative, right? It's not commutative. We must be careful in describing the domain of a composite fraction. The domain of G stroke f is equal to the set of those values. X satisfy the following properties. Here, G stroke f works on X. Like this. And first, G circle F. This means first F works on X. So X is in the domain of F. Otherwise, Fx is meaningless, right? So X is in the domain of F. And then G works on Fx. So this means Fx is in the domain of G, right? Otherwise, G works on Fx. It's also meaningless, right? So we should X satisfy the following properties. First, X is in the domain of F. Then Fx is in the domain of G. Then this composition of composition of G with F. This is maybe it's meaningful. And in other words, X must be a valid input for F. This means Fx must be a valid input for G, because we want to find this. So X must be a valid input for F, and F must be a valid input for G. In our example, the value X is 2 is in the domain of F. Okay. In our example, we find that G Fx is equal to G Fx and G Fx. Fx is equal to x minus 3 to gx square root of x. Okay. And we know x minus x is equal to is in the domain of G of F, right? For this one, we x is 2. The output is minus 1 over 2. So 2 is in the domain of F, but it's not in the domain of G circle F. This means G circle F is this one. We know Vx is 2. So this is 2 minus 3 over 2 with square root is equal to minus 1 over 2. Because this would lead to the square root of a negative number, right? So the domain for G circle F is an interval which lies the square root of a non-negative number. So this means x minus 3 over 2 should be greater than or equal to 0. We find x is greater than or equal to 3. So the comparison function has the domain is 3 infinity, because Fx is non-negative on this interval, and then the input G to G must be non-negative. And the domain for F circle G is interval 0 infinity. F circle G, we find F circle G. F circle G, we find here. F circle G is square root F and 3 over 2. We find the domain, which notice just the X is greater than 0. Okay. Right? So we find the domain F circle G is in the interval 0 to infinity. So we see that the domains of G circle F and F circle G may be different. Now, figure 3 shows how the domain of G circle F excludes those values of X, for which Fx is not in the domain of G. Maybe, Now, we should know how to find the values of comparison functions. First, we have the example 2. This is Fx is 6x over x squared minus 9 and gx square root of 3x with their natural domains. First, we find this one. F circle G 12. First, we should find the composition function, composition f with g or of t. This is equal f circle g x, right? Is equal to f gx. We find gx is this one. So right? Right? And this means input is the square root of 3x. Input x, we have this one. If input the 3x square root, this is 6, right? Over the square minus 9, right? So we find this is 3x minus 9. Right? And then we find that this means x is 12. So f circle t 12, we find is equal to 6 times 3 times 12 over 3 times 12 minus 9. So we write this is equal to, this is 36, 6 over 4/3, right? 4/3 find. And find f circle g, we already found it. And give is domain, Give is domain, which just notice square root of 3. We have this is greater than or equal to 0. This means x is greater than or equal to 0, right? The domain we write in the interval notation. It's 0 to infinity. We just finished it. Oh, we should notice that 0 to infinity. We should also notice that 3x minus 9 is not 0. We should exclude this point, right? So we should exclude. This means x is not 3. And in 3 is in this interval. So we must exclude 3. Exclude 3. We write the domain is 0 to 3. You need 3 to infinity, right? This means we have exclude the point 3. And questions? This one. Yes, we will have the same answer. This is first we consider the square root of negative number, and then we will exclude the point, exclude 3 to avoid division by 0. So the interval domain is 0 to 3. You need 3 to infinity. Okay, and no problem, we continue. And in calculus, we will often need to take a given function and write it as a composition of two similar functions. This means you know how to find the composition function. You should also know how to write it as a composition of two similar functions. Usually, this can be done in a number of ways. For example, px is the square root of q plus 4. This can be right. Okay, this is a composition function. Composition. We can write this one. Write px as a composition of two simpler functions. This can be done in a number of ways. For example, alright, this means we can decompose px. Alright, first I write px is I write like this. Maybe I write u is x squared plus 4. And I write px is the square root of u. Or if you, I can also write not just u, I can write px, a new function, this p, I don't write px, write fx is square root x, and write gx is x squared plus 4. Now, the px can find is equal to f circle g x, composition f with g. This is f gx, and I will check it. F gx is x squared plus 4. Fx is the square root x, so it's the square root of x squared plus 4, right? This means we can decompose a composition function, or we can write it as a composition of two simpler functions, right? You write like this. And also, we can another way, you write like this. Another way, method 1, method 2. The px is the square root of x squared plus 4. All right, fx is equal to maybe fx is equal to x plus 4. And gx, all right, is equal. Oh no, right, gx is equal. Okay. Px fx, right, sorry, right like this, simple, like this. And gx, right, is x squared. Now we find this one, I find this is f gx is equal to gx is x squared. Fx is square root x plus 4. So right is like this, x squared plus 4, right? So there's different ways. But this means this can be done in a number of ways. We can decompose this function. Okay. And we already check both of these compositions. If px is this one, and this is called the decomposition. This is decomposition. Px is gfx with fx is square plus 4, and gx is square root of x. This one is just and simpler and usually preferred. We can therefore where px is the square root as a square root of function x. This way of looking at function will be important in chapter 2. This means this is very important to decompose px. And for example 3, try to write the function px as a composite function g circle f. This means you should find the proper g and f. And then g circle f is equal to px, right? Okay, you should try. You should have a try. Maybe different students have different ways. Okay. Different students have different ways, methods, and you can check whether you are right or wrong. Anyone finished? Hello? Okay. GX. Oh, yes, different ways. Let me see. First, GX is equal to X plus 2. X is X power 5. So right is FGX, we find is equal Fx plus 2 is equal X plus 2 power 5. This is method 1, right? And X plus 3. Yes, right. Okay, and we see. This is the most obvious way to decompose P is to write. It's called decompose P. Px is Gfx, where Gx is x power 5 and Fx is x plus 4. With that view, Px is equal to x plus 2 power 5 as the fifth power of our function x. Of our function of x. And we will continue to learn some important functions. We are partial log of functions. A function of the form fx is k, where k is a constant, is called a constant function. Its graph is a horizontal line, big bang. This is big bang. This is a constant. The graph. The function fx is x is called the identity function. Its graph is a line through the origin having slope 1. From these simple functions, we can build many important functions. First, we have the polynomial fraction. Any functions that can be obtained from the constant functions and the identity function can be used of the operations of addition, subtraction, and multiplication. It's called polynomial fraction. This amounts to things right. F is a polynomial function. F is a form, is of the form. This is a polynomial function. The an x power n plus an minus 1, the power n minus 1 power x plus a1x plus a0. Here, this is a, or this one a minus 1, a0 are real numbers, and n is a non-negative integer. If a is not 0, n is the degree here. The degree of the polynomial function degree. In particular, we have fx is ax plus b. This is a first degree polynomial function. Then this is the power 1. So the degree is 1. We will rate its first degree polynomial function or linear function. Fx is ax cubed square plus bx plus c is called a second degree polynomial function or quadratic function. Portions of polynomial functions are called rational functions. They will learn. Function. The numerator here is the polynomial function, also the denominator. Thus, if f is a rational function, it is of the form like this. And the domain of a rational function consists of those real numbers for which the denominator is not 0. This means this is not 0. Not 0. and we learned the polynomial fraction, the rational fraction. And maybe just this is not homework, it's just exercise for 7C, number C, and find B. Okay, only two. Because they are easy. Six, they are easy. Quickly, exercise. Number C and number D. Number B. Try to finish the okay. Oh, I will add one. F. F. over A. We can check it. Sin 80 plus 2 pi over A. Let's see whether is equal to sin 80. Right? We can find is equal to we can find sin 80. Oh, sorry, like this. This is sin 80 has a theoretic is 2 pi over A. Here, this is right. Is sin 80. We know if it's periodic, we know if P plus P is at T, right? P is periodic. So we find this is T plus P is A here. T is here. T plus pi over 2 pi over A, right? It should be like this, not this one. So we write is 80 plus 2 pi, right? You know, 80 plus 2 pi is also equal to sin 80. So this means the period of the fraction sin 80 is 2 pi over A. Also, cos 80 is also 2 pi over A. And we find C plus A, sin 80 plus B, and C plus A, cos 80 plus B have period 2 pi over A and amplitude is A. Here is amplitude A. Also, we have 4 other trigonometric functions. We could get by with just the sin and cosine functions, but it's convenient to introduce 4 additional trigonometric functions. It's tangent, cotangent, secant, and cosecant. Tangent is sin t over cosine t. Cotangent t is cosine t over sin t. Secant t is 1 over cosine t. This is new one, right? It's 1 over cosine t. And cosecant t, this is also a new one, is 1 over sin t. And we have 2 additional identities, except we know this one. We are familiar with this one. Now we add 2 identities. Is equal to 1 plus tan square t is equal to secant square t. This one is new. And we can compare it. 1 plus tan square t. We can write is 1 plus secant sin square t over cosine square t. Right? We can write is cosine square t. This is cosine square t plus sin square t. Right? And we know here the numerator is 1. So it's 1 over cosine square t, right? So this is equal to, 1 over cosine t is secant t. So it's secant square t. We just write. And similarly, you can put this one. 1 plus cotangent square t is cosecant square t. You can also write with a similar way. Okay. This is new. These are new. And trigonometry. Angles are commonly measured. Either typing mistake. Teacher may be typing mistake. Cosine square. What? Which one is wrong? Where? Typing mistake.